This episode will be solving more questions on standard form. So we'll try to convert numbers from the ordinary form to the standard form. The first question we have is 5.26. I want to convert it to its standard form. And you can see that it's a number that is bigger than 1, right? So this is 5.26. Now, remember one thing, what do? We decide to move the decimal point to the left here. We have something like 0.536. And this 0.536 now is a number that is less than what? 1. So obviously it can't be in standard form. So what do? So I would say what would be specific? Simply to say 5.26 times 1. Right? Since any number times 1, give us the number. 5.26 times 1. 5.26 times 1. So this is now equal to 5.26. We call that we learned in indices that any number raised power 0 is 1. That is, if I have 2 raised to power 0 is 1. 3 raised to power 0, 1. Except 0. 3 raised to power 0 is not 1. I think I explained that in one of my shorts. 0 raised to power 0 is not 1. For all other numbers, 6 power 0 is 1. Similarly, 10 raised to power 0 is also 1. And we know that in standard form, the base we are dealing with here is what? 10. So I can replace this one with 10. I would say 10 is to power 0. I would have clear. So now if I write 5.36 times 1 and then 1 is 10 is to power 0. So 5.36 times 10 is to power 0. So you can see the conditions are appropriate. 5.26 say the number between 1 and 10, right? And then the 0 here is an integer. So 5.36 times 10 is to power 0 is the standard form. Right? We have another number here, 68. This is a number that is also greater than 1. What do we in this case? We simply write it as 68.0, right? 6.0. Then decimal point is shifted to the left just once, 1. Right? That's equals 6.80 times 10 is to power 10 is to power 1. You can see move decimal point just once, right? Our rate is 1. Why is it now positive? It's positive because the original number we converted is greater than 1, which is 6.8 times 10. 10 is power 1 is 10. 6.8 times 10. That's the number in the standard form. Number 3, we are still on a number greater than 1 as 77650. We write this as 77650.0, right? Now shift decimal points. The left, like we usually do, we have 1, 2, 3, 4. I said do not shift the number beyond the last number there. The last number here is 7, right? So do not shift the number beyond 7. And then this is now equals 7.7650 times 10 is to the power. What will be the power of 10? Because the original number we are converting is positive, so it is 10 is to the power, a positive number, right? What is the number exactly? How many times did you move the points? And that's 1, 2, 3, 4. You move the points 4 times. That determines the power of the 4. That's 10 is to the power 4. And this is now 7.765 times 10 is to the power 4. It's only the zeros that come after the decimal points here that is not significant. We have any other numbers like 2, 3, they are significant and you must not leave them out. You can say I wrote 7.765 times 10 is to the power 4. It's only the zero there that is insignificant. That be number here greater than 1. That's 250. Yes, I think that is 250, right? 0.0. Right, so 1, 2. They said you must not exceed the last number, left hand side. Do not take decimal point beyond it. So, and then this is now equal to 2.5 in view, right? 10 times 10 to the power. How many times did that move decimal points? That's 2 times 10 to the power 2. That's 3.5 times 10 to the power 2. How do I know that it's a positive power? Because the original number I'm converting was the number greater than 1. Therefore, the power of 10 is positive. That will be plus 2 and not minus 2. Now let's move to numbers less than 1. Let's convert it to the standard form. What number I have is 0.886. 886. Here, the decimal point is removed to the right? So now the question here, let's ask ourselves is, where should I stop? Now I have a 0.886. Should I stop here? Move forward here. As move forward here. Remember the definition of a number in the standard form, which is a times 10 to the power 10, 10 to the power n, right? And then you said the a here should be a number between 1 and 10. That's what we should always account for. Number should always be between 1 and 10. Now, you have to place decimal point in such a way that the number we have there is between 1 and 10. And let's now see. Here we have 0.886. So I place the number here. After 8 here. Oh, I would have 8.6, right? But move the decimal point a step forward. I would have 88.6. I move decimal a step forward, I would have 286. Which of these things should I do? Obviously, I should pick the first one. Why? This number is between 1 and 10, and that's the correct one. That's telling us that in this case, we have to move decimal points just once. And that's first one. That's we have 8.86 times 10 to the power. Now, the one is equal to plus 1 or minus 1. The minus 1 because the original number I converted to this standard form is a number less than 1. That will make me make the power here negative power and not positive. This question we have here 0.78. This gives us there are two possibilities. 0.78. And decide to take decimal points plus one step here. I would have 7.8. I'll try to take it one step forward. I have 78. Which should I choose? Remember the principle for standard form. Number A has to be between 1 and 10, right? So between 7.8 and 78, which is between 1 and 10, obviously 7.8. I'm going for 7.8. That means I remove decimal point here just once. 1. And that's what 7.8 times 10 to the power. It will be negative power, right? Why? Because the original number is 0.78 is less than 1. So would that be negative power? Then what would that be the number for the power? The number would be 1. Why? I mean decimal place just once. Decimal point just once. Then 1. Right? Number 7. 0.000167.54. And this is equal to also 1, 2, 3, 4. If you take the number, the decimal point beyond 1. All the numbers we have will be wrote more than 10. You see, we take it to 6, we have 16 point something. Take it forward, we have 167. Take it forward, we have 1000 and something. Take it forward, we have 15,000. But if we leave it between 1 and 6, we have what? 1.6, which is what we want. Between 1 and 10, right? That's 1.67254. And times 10 to the power what? It 10 to the power minus something. It's minus because the original number is less than 1. So minus what? How many times did I make the decimal point? That is 1, 2, 3, 4. That's just 4 times 10 to the power minus 4. Okay, let's see some questions whereby we either add or subtract numbers from standard form. The first question will evaluate. Evaluate. We have evaluate 4.2 times 10 to the power 5. Then plus 2 times 10 to the power 2. This is the answer in standard form. After evaluating, let's give the answer in standard form. Now, the easiest way to do this is to try to convert the two numbers to ordinary form, then add. After adding, convert the final type of standard form. That's the easiest way of doing this. Now, for the 4.2 times 10 to the power 5 to ordinary form, how do we beat? Then remember, I will simply say 4.2 and then times 10 to the power 5, right? Remove decimal points 5 times to the right. Obviously, 10 to the power 5, that's plus 5 to the right. Remember, right for plus, left is for minus. So we have 1, 2, 2, 4, 5. Decimal point here, right? And then those empty curves, fill them in zeros. That's 4, 2, 0, 0, 0. Then 4, 2 times 10 to the power 2. That's simply 2.0. Next to the is a whole number, which is 0. Then also 10 to the power 2, 2 plus power plus 2. Move to the right 8 times. 1, 2, 3, 10.0. What did you also replace this with 0, 0, and then 0? That's 3,000, right? Let's now add 4, 2, 0, 0, 0, 0, then plus 2,000, and right? Plus 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0, 0 plus 2, 2, and then 2, and then 4. They are done adding, right? I convert this back to standard form. That's the next one to do now. So how do we do that? Simply read from 0 to the right, then now take the decimal points back to the right, the left, rather. 1, 2, 3, 4, 5. We said don't go beyond 4, right? Don't exit 4. Don't go beyond 4. So that our number will be between 1 and 10. But once you go beyond 4 now, you have something like 0.4. So our number is between 1 and 10. That will, if you stay between 4 and 2 now, we have what? We have 4.2, right? 10 times 10 used to power. What will be the power? How many times we do with decimal terms? 1, 2, 3, 4, 5. Times 10 is power 5. That's the answer. That's form. With this, you will need to add the two numbers, and then we will get our answer in standard form. As simple as that. We have a similar question. Express the sum. Express the sum of 3.4 times 10 to the power 3 and 3.6 times 10 to the power 2 in standard form. How do we do that? We are adding 2.4 That is about 3 plus 8.6 and 10 is power 2. Answer must be standard form. So do this like we did the other question. Convert both to ordinary form first, then add them and convert back to standard form. So 3.4 times 10 is power 2 in ordinary form. So 2.4, right? So 10 is power 2. We have a power of 3. Move the decimal point to the right. 3 times 1, 2, 2, and 0. 3 is 0, 0, 0. That's 2, 4, 0, 0, and 0. As for 2.6 times 10 is power 2, that equals 0.6, right? So times 10 is power 2. Move decimal points twice to the right. Around, I should decimal point 0. Then do this with 0. As 0.60, right? From 0. Then add the 2. 2, 4, 0, 0, and 0. 0.62 and 0. 0, 0 plus 0, 0, right? 0 plus 2, 6. 4 plus 2, 7.2. 2,760 in a standard form is simply when we click 0 here, right? And then decimal point, left hand side, around 8, 8, maybe between 2 and 7, right? So that we have a number 1 and 10. Because if you leave it between 7 and 6, what we have? We have 7.6. Yeah, if you leave it this way, 7.6, which is not 1. And also if you take it further, beyond 2, you have it as 0.27. No, so what we want. Because we want is 2.76. A number between 1 and 10. Wrote wrong, right? That's 2.76 times 10 is to power. What would the number? We move the decimal points 3 times. 1, 2, 2, 2. So that's our results in standard form. Finally, in this episode, back to simplify this question. Simplify 6.6 times 10 is power 7 plus 4.4 times 10 is power 6. Expression of in standard form. So we apply the probably the same as 6. And that is converting both to ordinary form separately, adding the results, and converting the results back to standard form. So this is 6.6 times 10 is power 7. Telling us that we'd have to fix decimal points to the right 7 times, 7 steps. 1, 2, 3, 4, 5, 6, 7. 0.0. We do with zeros. 0, 0, 0, 0, 0, 0. That looks when we're in looks is 1, 2, 3, 1, 2. The second one is 4.4 times 10 to power 6. It's mirrors to 4.4. Move 0 to the right hand side 6 times. 1, 2, 3, 4, 5, 6. Then the empty box with zeros 1, 2, 3, 4, 5. So that is 4, 4, 0, 0, 0, 0, 0. Then at 6, 6, 0, 0, 0, 0, 0, 0. Then we add this also 0, 0, 0, 0, 0. And see there are 5 you say, right? Then 4, 4. For the 4, 4, there are 5 there. So we clean the 5 zeros first and then the 4 and 4. So we add, we have 0, 0, 0, 0, 0, 0, 0 plus 4, 4, 6 plus 4, 10, 2, 2, 1, 0, and 6 plus 1, 7. Right, convert back to standard form. If you left hand side, shift decimal point further. 1, 2, 3, 4, 5 is 7. 7 times, that's 7.04 times 10 to the power 7. Why did I make the power here positive? That's because the inner number I converted will be number greater than 1. That's what makes the power here be positive. 37. Why is it 7? Because I move decimal point to left hand side 7 times. Why someone might ask why didn't I stop after 7? That's because what I have is 0.704. The Wayne's principle that state that it has to be between 1 and 10. Also, if I stay between 0 and 4, that will be 70.4. Also, this number is going between 1 and 10, right? So I have to stay between 7 and 0. So that I would have 7.34. So with this, we come to the end of standard form. Have a nice day. Try to suffer to our time.